Good afternoon, everybody. I'm Matt Przybyciel from ES Industries. I just wanted to go over some recent work that we've done with introducing sub 2 micron columns for SFC. SFC, for those that are not familiar with the technique, carbon dioxide is primarily the mobile phase. It does include occasionally polar modifiers such as methanol, ethanol. It's inherently a green technique. You can actually recapture the CO2 and recycle it. And this is a greenhouse gas that's captured for doing chromatography. So it really is a green technique. One of the things that we're discovering as we get more and more into it is its flow characteristics and back pressure are much more favorable than traditional LC. So that coupling columns of small particles with SFC is actually quite straightforward, but of course you have to take into account all the dead volumes and so on that you normally do with high performance HPLC or UPLC. The technique has been coupled with mass spectrometry now. It's been used in conjunction with mass directed techniques for building libraries and isolation of compounds. And as this gains more interest, we'll see more techniques that are using SFC mass spec. Works very well for small molecules. There are a number of applications that have been performed by supercritical fluid chromatography. The range of molecules are increasing as the technique becomes more widely used, more widely understood, and one of the things that makes it easier to use are the quality of the SFC columns that we've developed. And so some of the applications are actually including some peptides and some proteins now. We're actually seeing some work being done in that area. It does excel at preparative chromatography. It is a great technique, front technique for doing preparative chromatography because your mobile phase is CO2 and it goes away pretty easily, and you don't have a lot of solvent recovery and so on, or solvent stripping. What does the sub 2 micron bring to SFC? Well, it brings pretty much the same things that it does for LC. You get high resolution, high speed analysis, and the combination of high resolution and high speed analysis. And again, the back pressure characteristics in SFC, since CO2 is much more permeable to the packed bed than straight liquid would be, is much more favorable, and you really can push the flow rates up quite high on these columns. This is just a typical of a 5 micron. This is done on a diethylamino propyl stationary phase. One of the areas involving SFC is the development of specialty stationary phases for SFC. You could use diol, cyanose, silica, but a lot more is to be gained from the technique by using specially designed stationary phases. And this is another example of, this is on a 1.8 micron column. This is an ethylpyridine based stationary phase. And we use methanol as a modifier here in CO2. So we've introduced a number of sub 2 micron products for SFC applications. Ethylpyridine, pyridolamide, we have a nitro, we have a PFP, a basic, a silica, a pi phenyl, which has an increased pi interaction, a diethylamino propyl, and a amino phenyl stationary phase. And we're continuing to develop and introduce more of these stationary phases over time. You can find more about each one of these stationary phases, a further description of each one at our website at esind.com.